If you're lost with GED science and don't know where to start, don't worry, because I made this video to help you learn some basic skills and key concepts to help you build a foundation to make harder questions easier as you progress with your studying. Let's get started. Newton's second law of motion states that the acceleration of an object depends on both the mass of the object and the force acting on it. Please use the table below to help you answer the question. So the question says, when the acceleration is held constant and the force is doubled, what happens to the mass? Is the answer A, B, C, or D? So now's your chance, if you'd like to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. So these types of questions are important to know how to beat because I have seen examples like this on the GED testing service practice samples that they put out. Now, on the real test, most likely you're going to have more than two cases. In this example, we've got case 1 and case 2. But on the real test, they might give you 3, 4, or even 5 cases. But we're going to start here to help build a base. And basically what we see here is that in case 1, we've got 8, 4, and 2. And in case 2, we've got 16, 4, and 4. And we see that acceleration is 4 in both cases. So acceleration is held constant. So when the force is doubled, like it is from case 1 to case 2, the force doubles, what's going to happen to the mass? So that's the question we want to answer here. So if we look at the mass, we see that in case 1 it's 2, and if we look at case 2, the mass is 4. We can tell that the mass is doubled. All right, so again, when the acceleration is held constant and the force is doubled, we see that mass also is doubled. So the correct answer here is B. Newton's second law of motion states that the acceleration of an object depends on both the mass of the object and the force acting on it. Please use the table below to help you answer the question. Now this time it says, when the mass is held constant and the force is doubled, what happens to the acceleration? Is the answer A, B, C, or D? So let me give you a chance now to pause the video, try to figure this out, and whenever you're ready, just unpause the video, and whether you get it right or wrong, we don't care right now because this is just for practice and for learning. And whenever you're ready, just unpause the video and we'll talk about the question. Okay, so for a case like this, we see that now we've got 3 different cases to check, and the process is a little different than the last question, but it's also pretty similar. So the key here is that we have to see that it's asking about when the mass is held constant. So what I'm going to do first is I'm going to look at the different cases here. So let's call 25 and 4 case 1, 15, 3, and 5, let me call that case 2, and this 40, 10, and 4, let me call that case 3. And I'm just calling these case 1, 2, and 3, so it's a little bit easier to talk about here. So the first thing I want to do is find 2 cases where the mass is held constant. So we see that in case 1, and in case 3, the mass is it's 4 in both cases here. All right, but in case 2, it's 5. So really, I can just take case 2 out. I don't need to look at case 2. It's not going to help us get the question right here because we want to find cases where the mass is the same. So 1 and 3 are the cases we want to look at here. So the question says, when the mass is held constant and the force is doubled, what happens to acceleration? So the next thing I see is that in case 1, the force is 20. And in case 3, it's 40. So from case 1 to case 3, the force doubles. And I want to check what's going to happen to the acceleration. Now, here in case 1, we see that the acceleration is 5. And we come down to case 3, and we see that the acceleration now is 10. So we see here that when the mass is constant and the force is doubled, the acceleration also doubles. So the correct answer here is B. So again, on the real test, they might try to make this harder for you by giving you 4 or 5 different cases, something like that. They might also give you something that says, which of the following is supported by the table, and they'd give you answer choices A, B, C, and D. And you just kind of have to look at each statement individually and see if it matches what's going on in the table. And the key really is to just take the basic skills that we've covered in the first question on this topic and in this question here. Just stick to those basics, and I'm a big believer that if you understand the basics and apply them, you'll have a good chance at getting those harder questions right. And I do have several examples of these types of questions in my other practice test videos. According to the Cleveland Clinic, a total cholesterol level of less than 200 is categorized as healthy. A total cholesterol level between 200 and 239 is categorized as at risk, and a total cholesterol level of 240 or higher is categorized as dangerous. John's total cholesterol level was in the at-risk range. His doctor recommended that he try a new diet for a 6-month period. John followed all dietary instructions perfectly and found that his total cholesterol level decreased significantly at the end of the 6-month period. Which of the following is correct? A. The dependent variable is his new diet and the independent variable is his total cholesterol level. B. The independent variable is his new diet and the dependent variable is his total cholesterol level. So let me give you a chance now if you'd like to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. Independent and dependent variables can be kind of tricky when you're first learning about them. Basically, the independent variable is what we suspect will influence or impact the dependent variable, and the dependent variable is what occurs as a result of the independent variable. So here in this case, the independent variable is his new diet, and the dependent variable is his total cholesterol level. So the dependent variable, it depends, right? So he changed his diet and his cholesterol level dropped, right? So the change in his cholesterol level depended on him following that new diet, right? So the cholesterol level depended on his diet. So the independent variable is his new diet and the dependent variable is his total cholesterol level. Scientists use the pH scale to measure how acidic, basic, or neutral a substance is. Acidic substances have a higher concentration of hydrogen ions than basic solutions. Acid substances have a pH below 7, whereas basic substances have a pH greater than 7. The table below lists the approximate pH values for 5 different substances. And it says, please indicate whether each substance is an acid or a base. So now's your chance if you'd like to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. So basically, it tells us that acid substances have a pH below 7. So if it's less than 7, it's going to be an acid, whereas basic substances have a pH above 7. So let's go through these one by one. So milk of magnesia, the pH is 10.5, so that is greater than 7. So milk of magnesia is a base. So I'm just going to put a B here. So apple cider, is apple cider an acid or a base? Well, if it's less than 7, it's an acid. So 3.7 is less than 7. So I'm going to put an A here for acid. Now what about toothpaste? So toothpaste has a pH of 8.9. That's greater than 7, so this is a base. So for tomato juice, the pH is 4.1. 4.1, that is less than 7, so this is an acid. So let me just put an A here. And Mountain Dew has a pH of 3.05, so this is also going to be an acid because the pH is less than 7. So right here where it says next question, just ignore that. I typed that out when I was writing the questions, and it should have been deleted, but I didn't delete it, so I'm deleting it now with my pen. And just a quick recap here, just because I can't always read my handwriting, so I can't expect that you always can. Milk of magnesia is a base, apple cider is an acid, toothpaste is a base, tomato juice is an acid, and Mountain Dew is an acid. So the question says, based on the information in the table above, what is the ratio of acidic to basic substances included in the table? So now's your chance if you'd like to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. Okay, so the first thing I want to do here is count up the number of acids. So we have 1, 2, 3. So we've got 3 different acids. And now let's count up the number of bases. So we see we've got 2 different bases. So the ratio of acidic to basic substances is 3 to 2. So A is the correct answer here. I'm excited to announce that this video's champion shoutout goes to a test taker who says, I finally passed my GED math test. I'm officially a GED graduate. I'm off to college. And I want to give this person a big congratulations. And anyone out there that's watching this right now, know that whatever your goal happens to be, whether you want to pass the GED and then go on to college or go on for more schooling, or whether you want to go into a better job that you have in mind right now, or if you want to join the military, whatever your goal happens to be when you're done, just know that it's still ahead of you. I know it's easy to get discouraged from time to time. It's easy to start to doubt yourself when you feel like you're struggling or when you're facing a lot of adversity with your test prep. But just know that, I've heard many stories from test takers that have faced adversity and have doubted themselves, and they persevered and they passed. And if you keep going and if you stick with it, someday you can be done too. Matter is anything that has mass or takes up space. There are 3 states of matter: solids, liquids, and gases. When a solid becomes a liquid, we call that melting. The melting point is the temperature at which the state changes from a solid to a liquid. When a liquid becomes a gas, we call that boiling. The temperature at which the state changes from a liquid into a gas is called the boiling point. The table below lists the approximate melting and boiling points in degrees Celsius for rubidium, sodium, and lead. So the question says which element in the table above will be a solid at 120 degrees Celsius. So now is your chance to pause the video, try to figure this out, and if you get stuck, don't worry about it because we're just going to go over the answer. Okay, so let's talk about this question. So the process of a solid becoming a liquid is what we call melting. So when a solid becomes a liquid, we call that melting. And when a liquid becomes a gas, we call that boiling. So I like to have this diagram in mind here when I teach three states of matter questions. And here let's go one by one and look at each answer choice. So at 120 degrees, is rubidium going to be a solid, a liquid, or a gas? Well, we know that the melting point for rubidium is 39 degrees. So at 120 degrees, rubidium is going to be a liquid. Now the reason is because we know that it's going to melt at 39 degrees and become a liquid, but it's not going to become a gas until 688 degrees. So rubidium is going to be a liquid, and since we're looking for which element is going to be a solid at 120 degrees, we can eliminate answer choice A. So let's talk about sodium. Well, we know that sodium is going to melt. In other words, it's going to go from a solid to a liquid at 98 degrees. So at 120 degrees, sodium is going to be a liquid, but it's not going to be a gas yet because it doesn't boil until 883 degrees. So sodium is also going to be a liquid at 120 degrees. Now, what about lead? Well, we know that lead is not going to melt until 328 degrees Celsius. So if the temperature is 120 degrees, lead is going to be a solid still. So lead will be a solid until it gets to 328 degrees, in which case it will melt and become a liquid. So C, lead, is the correct answer. So the question now says which element in the table above will be a liquid at 900 degrees Celsius. So now's your chance, if you'd like to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. So let's go through the answer choices one by one here. So let's start with rubidium. So will rubidium be a liquid or a gas at 900 degrees Celsius? Well, let's look up here. We know that the boiling point of rubidium is 688. So at 900 degrees Celsius, rubidium is going to be a gas because the temperature is higher than the boiling point. So let's take rubidium out here because it's going to be a gas at 900 degrees. So what about sodium now? Well, if the boiling point for sodium is 883 and the temperature is 900 degrees, sodium will be a gas, right? Because it boils at 883 degrees. So sodium is going to be a gas. Now what about lead? Well, if we look at lead, we see that the boiling point for lead is 1,749 degrees. If the temperature is 900 degrees, lead is going to be a liquid. So the correct answer here is C, lead. So in these segments of my videos, what I do is I pop out from behind the screen and I give you a break from the learning and I answer a couple questions from a random question generator. And I've gotten mostly positive feedback on these segments, but if you think I'm just wasting your time by doing this, please let me know down below in the comments. I do take feedback seriously. What is your favorite ice cream flavor? Well, I would say I like mint chocolate chip, I like cookie dough, and I know this isn't ice cream, but I do like Rita's Italian Ice. My favorite flavor is mango. What is your favorite pizza topping? I like Hawaiian pizza with pineapple on top, but I'll also take pepperoni. Would you rather have summer weather or winter weather all year round? If I had to pick, I'd take summer weather. Two parents want to try to figure out the eye color of their offspring. One parent has a genotype of little b with blue eye color. The other parent has a genotype of big B little b with brown eye color. The offspring will receive one allele from each parent. The genotypes of the offspring are missing from the boxes below. For the offspring, the allele combination big B results in brown eye color, as does the allele combination big B little b. The allele combination little b results in blue eye color. And it says, please fill in the missing allele combinations and then determine the ratio of blue eye color to brown eye color for the offspring. Now, obviously, you won't really be able to fill in this chart through your screen, but maybe if you have a sheet of paper, you could write it down on a sheet of paper. And whenever you're ready, just pause the video, take all the time you need, and if you get stuck, don't worry about it because we're just going to go over the answer. Okay, so let's start off by filling in our chart, Punnett square, table, whatever you want to call it here. And so I'm going to take this big B and I'm going to combine it with the big B up here. So now let me come over to this box here. So I'm going to take my big B and I'm going to combine it with my little b. That's right up here. Now in this box down here, we're going to be combining a little b with a big B. And whenever you combine a lowercase letter with an uppercase letter, you always want to write the uppercase letter first. So in other words, we're going to combine this little b and the big B, but I write the big B first. Now in this box here, I'm going to combine a lowercase b with another lowercase b, so I'll just put little b right here. So now we can proceed with interpreting what we have here. Now we're told that big B is going to result in brown eye color. And we know also from our description here that big B, little b is going to result in brown color. So I've got big B, little b, and that's also going to result in brown. Now, when it comes to little b, we see that that's going to give us blue. And my handwriting is really sloppy, so I do apologize for that. But this little b is going to give us blue. So now let's determine the ratio here of blue eye color to brown eye color for the offspring. So if we look at our 4 boxes here, we see that only this corner right here has 2 little b's. So this corner right here is the 1 blue. And we see that there are 3 browns, right? Brown, brown, brown. So the ratio is 1 to 3. So D is the correct answer. Now, if you picked C, most likely what you did was you counted that there were 3 brown, and then you saw that there was only 1 blue, and you wrote it like this, 3 to 1. That would be correct if it was asking determine the ratio of brown eye color to blue eye color. But instead, it's asking to determine the ratio of blue eye color to brown eye color. So just be careful when you look at the order here, right? If this says brown eye to blue eyes, then it would be 3 to 1. But since it says determine the ratio of blue eye color to brown eye color, we do 1 to 3. Okay, so when all is said and done, D is the correct answer here. Great job if you got this right. If not, great job for trying. This can be a challenging concept to understand. Based on this oversimplified food web, which of the following would likely increase the perch population? Is the answer A, B, C, or D? So now's your chance if you'd like to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. So the first thing that I want to make clear whenever you get a question like this is what the arrows are showing, because the arrows can make these questions confusing. And if you get this backwards, you're going to have a really hard time getting the question right. So I just want to take a second here to make it clear that the arrows are always showing the flow of energy, not what eats what. Again, the arrows show the flow of energy. They don't show what eats what. For example, it'd be really easy to look at this and think that the crayfish must eat the perch because the arrow points from the crayfish to the perch. And it'd also be easy to look at this and say, well, the perch must eat the northern pike because the arrow is pointing from the perch to the northern pike. And if you looked at this and thought that, I can totally see why you would think that, but I just want to point out that it's actually the other way around. The arrows are showing the flow of energy. So the way to think about this is that the perch eat the crayfish, and energy then flows from the crayfish to the perch. Same with the northern pike. So the northern pike eat the perch, and energy flows from the perch to the northern pike. All right, so again, it's really easy to look at this and think that the arrow is showing that the crayfish eats the perch, but it's actually the other way around. And I know that this can be confusing, which is why I'm going on a mini rant here and I'm just repeating this over and over and over again. You're probably going crazy. You're probably getting tired of me saying it, but I just want to point out here one more time that the arrows always show the flow of energy. They don't show what eats what. So in this diagram here, food web, whatever you want to call it, the perch eat the crayfish and the northern pike eat the perch. Okay, so with that said, now I'm going to actually walk you through the question here. I just wanted to really make it crystal clear that the arrows show the flow of energy. They don't show what eats what. So the question says, which of the following would likely increase the perch population? So let's finally walk through this now. So let's look at each one by one here. So A, decreasing the crayfish population. So what's going to happen to the perch population if we decrease the crayfish population? Well, remember, the perch eat the crayfish. So if we decrease the crayfish population, there's not going to be as much food for the perch. And if there's not as much food for the perch, sadly, more of the perch are going to starve and they're going to die out. So if we decrease the crayfish population, most likely the perch are going to die out as well. They're going to decrease as well because there's not going to be enough food. So A is out here. So what about B? Increasing the northern pike population. Well, the northern pike eat the perch, right? So if we add more northern pike, there's going to be more pike to eat the perch, right? So if the perch, they have to run and hide and flee and try to get away from the northern pike, and we now have more northern pike, more perch are probably going to be eaten. And if more perch are eaten, that means that the perch population is going to decrease. So increasing the northern pike population is going to decrease that perch population because there's more pike around to eat the perch. So what about C, decreasing the northern pike population? Well, if the pike eat the perch and there are fewer pike around, the perch are then most likely going to increase in population because there aren't as many predators around to eat them. So the correct answer here is C. Is the following chemical equation balanced? A, yes, or B, no. So let me give you a chance now to pause the video, try to figure this out, take all the time you need, and whenever you're ready, we'll go over the answer. Okay, so let's talk about this question now. So basically, here we have to figure out if this is balanced or not. So the way I recommend doing that is to just start by looking at everything on the left-hand side first and take stock of what we have over here. So when I say left-hand side, what I mean is everything to the left of the arrow. So my C5, my H12, and my 802. So that's my left-hand side. So let me just take stock of what I have. So how many C's do I have on the left-hand side? Well, I see a C and this little 5 next to it, so I know that I've got 5 C's over on my left-hand side. Now, what about H's? How many H's do I have? Well, I see H with the little 12 beside it, so I know that I've got 12 H's. Now, what about my O's? Well, here is where things get a little bit trickier. So I see that I've got an 8 out in front of my O, and I've got this little 2 right here beside my O. So how do I handle that? Well, I'm going to do 8 times 2. So 8 times 2 is 16. So on my left-hand side, I've got 5 C's, I've got 12 H's, and I've got 16 O's. So now let me come over here and let me work on the right-hand side, and let's take stock of what we have over here. So when I see that I've got 5 CO2, this tells me that I've got 5 carbons over here. And what I'm going to have to do for the O's now is I'm going to have to do 5 times 2 for my O's, because the O has this little 2 next to it. So 5 times 2 is 10. So far I've got 10 O's. So now let's come over to the 6H2O. So how many H's do I have here? Well, I have to do 6 times this little 2 here. So 6 times that little 2 is 12. So I'll have 12 H's. And what I also have to do is I have to take into account the fact that I've got 6 more oxygens here, because there's this 6 out front of everything, and there's an oxygen here. So I've got 6 more oxygens to deal with here. So I do plus 6 here. So I see that in total, I've got 16 oxygens on the right-hand side. So let's count them up. We've got 5 carbons on the left, we've got 5 on the right, we've got 12 H's on the left, we have 12 H's on the right, 16 O's on the left, and 16 O's on the right, so everything is balanced out here. And this is one of those things where it can be kind of tricky at first until you've seen a couple examples, but if you go through a couple examples of this, hopefully you'll find that these aren't that bad, even though they might seem tricky at first. What is the mean density of the sample provided in the table below? And we see a formula for density here. It says density equals mass divided by volume. And we see a table here and it says, please write your answer in the box below. And obviously you won't really be able to write your answer in that box through the screen, but maybe you could write it down on a sheet of paper or whatever you have nearby. And let me give you a chance now to pause the video. Take all the time you need with this. If you get stuck, don't worry, because we're just going to go over the answer. So let me give you a chance to try this now. Okay, so let's talk about this question. So basically what I want to do first is I want to calculate the density for each sample. And we can do that using this formula here. So let me calculate the density for sample A. So the way that we're going to set it up is we're going to do the mass divided by the volume. So in other words, we're going to do 4 divided by 30. And in my calculator, when I do that, here's what I get. I get 0.133 and a bunch of threes. I'm just going to leave it as 0.133. Now let me do the same with sample B. So for sample B, how I'm going to set it up is I'm going to do mass divided by volume. So that's going to be 2 divided by 21. And let me do that in my calculator. And when I do that, I get 0.095. And I don't really care how you round. I'm just going to leave it as 0.095. I don't really care how you round your final answer either. This is just for practice. But this is how you would do the first steps here. I could do the same with C. Let me get the density for C. I would do 6 divided by 25. And that's 0.24, which is a nice simple number to use here. And then let me write D up here to save some space. So D, we do the same thing, mass divided by volume. So I'm going to do 9 divided by 35. And that gives me about, let's say, 0.257. So now that I have all the densities calculated, the trick now is to find the mean. So what I'm going to do is I'm going to take all of these numbers. So I'm going to take the 0.133 and I'm going to add that to 0.095. Then I'm going to add 0.24. Then I'm going to add 0.257. So all I'm going to do here again is I'm just going to take all of the numbers and I'm going to add them up. And then I'm going to divide by 4. Now you might be wondering, why are you dividing by 4? Well, the reason I'm dividing by 4 is because we've got 4 different samples here. Okay, so whenever you need to find the mean, all you do is you add up all the numbers and you divide by the total number of numbers, right? So here we've got 1, 2, 3, 4 different samples. So I'm going to divide these by 4. And again, I don't really care how you round, but the answer should be something close to this, 0.181. And it might be a little different depending on how you rounded, but it should be pretty close to this. And again, here's the process. All we do is we find the density for each sample by doing mass divided by volume. We're going to add up all the densities and divide by 4. And your answer should be 0.181 or something close, very close to this, depending on how you round it.